Hi, my name is Marlene Garcia, and my presentation will be about breast cancer. So the data set that I chose was from Kaggle, and I was able to get into 3 sub-data sets, which would be the undertreatment patients who are recovered, and patients who have died. This is all just one whole data set, but it's divided into 3 subsections. They have the same variables but different outputs, and they were created to determine if the tumor would be benign or malignant. There are a total of 30 variables, but only 5 variables will be used. My response variable would be the thickness of the tumor since it's quantitative, and it would just be the density of the tumor detected in the patient's body. There are a total of 4 predictors. My first predictor is breast pain, and this is just if the patient has pain in the breast. 0 would mean that they have not experienced pain, and 1 that they have experienced pain. Next is the hereditary history. This ranges from 1 to 0. The 1 would mean that they do have history of this disease, and 0 would mean no, they do not have history of this disease. Our next predictor would be radiation history, and this would just mean that if they have experienced radiation, it would be a 1, and if they have not experienced radiation, it would be a 0. As well as for birth control, it would go from 0 to 1. 0 would mean that they have not taken birth control, and 1 would be that they have. So my first research question is there any relationship between the thickness of the tumor and the breast pain for model 1, which is the model that I created using R within the 3 datasets? The conclusion that I reached is that in the undertreatment dataset, there was a p-value of 0.29, so you can see right here. And this led me to assume that there is no relationship between, so there is a relationship between these 2 variables. Now, in the recovered dataset, I realized that the p-value is 0.91. Since the p-value is higher than 0.5, it led me to not reject the null hypothesis. So this just is telling me that there is no relationship between these 2 variables in this dataset. Now, in the death dataset, the p-value was 0.018. And since the p-value is pretty low, it led me to reach the conclusion that there is a strong relationship between these 2 variables in the dataset. And this first one is just the linear model that I created to find the relationship between the thickness of the tumor and the breast pain in the undertreatment dataset. And this linear model is also the thickness of the tumor and the breast pain, but in the recovered dataset. And then this next linear model, it's just with my response variable, which is the thickness of the tumor, and then my predictor, which is just breast pain in the death dataset. Now, my next question is, what can be assumed about radiation history and the thickness of tumor within each dataset if the null hypothesis is rejected? Now, the conclusion that I came up with is that since the null hypothesis is rejected in the undertreatment dataset, it can be assumed that there is a strong relationship since the treatment and the radiation history is decreasing the thickness of the tumor. Since they are recovered, the null hypothesis is very low. And then this indicates that there's a strong relationship between both variables. And this could also mean that the treatment has worked with the radiation history background, and it has decreased the tumor significantly, if not completely. For the death dataset, I got that the null hypothesis is not rejected. Since there was no relationship between these 2 variables, it can imply that radiation history was not present, which could have increased the thickness of the tumor, which could have led to death. My next research question is, by adding more predictors to model 1, will it change the outcome of the analysis? I ran a multiple linear model regression, and I included the thickness of the tumor, birth control, breast pain, radiation history, and hereditary history. And this is just during the undertreatment dataset, and I found that by adding 2 or more predictors to the model, the outcome of the analysis completely changes. For the undertreatment dataset, the p-value increased by 0.02. In the first model that I used, the p-value was 0.299, and in this one, the p-value increased by 0.2. And there's still a strong relationship between the three predictors that were added. For the recovered data set, the p-value decreased by 0.7. I honestly thought that it would increase, but I was proven wrong by making the multiple linear regression model right here, and I used the same predictors for the recovered data set. And then this is what I got for the p-value right here. And then then this now shows that there's a relationship between the predictors that were used. For the death data set, the p-value went up by 0.5. There is no relationship between the predictor and the response variable right here. And that would be all that there is for my presentation.